The main topic of lecture 20 is nested if-else statement. But first we need to finish the discussion of the Boolean expressions from the previous lecture, lecture 19, in which we did the example of telling the user to enter two positive numbers, and we were checking whether the divisor should not be equal to 0, otherwise it was creating some kind of it was actually crashing the program. And we also use something known as a short circuiting, because if this condition is false, this thing should not be evaluated, because we were using the AND operator. So a Boolean expression such as this is a condition that is either true or false. So the result of this expression would be either 1 or 0, or true or false. So in this example, this thing is a Boolean expression, and we have seen that Boolean expressions do evaluate to integer values. So the value 0 means false, and every non-zero value means true, which we discussed in lecture 19. So since all non-zero integer values are interpreted as meaning true, Boolean expressions are often disguised. Let's say if we write a statement somewhere over here, I'm just commenting it, it's not part of the program, but if I'm writing the statement if, and I write n, then see out, which we discussed in previously, that n is not 0. So this statement will run only when n is not 0. I mean, any other value other than 0 is taken as true, because when the Boolean expression is interpreted as true, that means that any value over here is non-zero over here. Writing another example, let's say if I write if n remainder d, we see out, I'm going to say that n is not multiple of d. I mean, this is a comment over here, but let's try to understand what this statement means. This statement, this cout statement, will only run when n percentage d is not 0. I mean, n remainder d is not 0. That means that if we have numerator or n is 10 and d is 2, so the remainder is 0. That means the evaluation of this condition will yield to 0, therefore, which is false, therefore cout will not run. However, if we have something like n equals to 11 and d equals to 2, so 11 remainder 2, you divide 11 by 2, the remainder is 1, or that means that this condition becomes true and this cout will run. And take another example. Let's say n equals to minus 15. Minus 15 remainder 2 is the remainder is not 0, so I think it should be somewhere around 5 or minus 5 or whatever. So that means that this n is not a multiple of d would be printed on the screen, because any value other than 0 is taken as true. Let's write another example. I've already saved this file, named it, and written all the prerequisites to write a C++ program. So it's not going to prompt me to save this file and so on and so forth. Okay, so let's write an example. Let's declare some variables n1, n2, and n3, and I'm going to say to the user that enter 3 integers. So and I'm expecting the user to enter integers and not any other floating point value. So I'm to take the input from the user, and using the input operator, assign the first input as entered by the user to n1, the second input goes to n2, and the third input is assigned to n3, as we have done before. Now pay attention over here. If I write, I'm going to figure out if, I'm just writing a simple statement, I want if n1 is greater than n2 and greater than n3, so I'm going to write maximum value is n1. So I'm going to write, even though this might create some problems, so let's watch out. So if n1 is greater than n2, okay, and or let's write greater than or equal to n2, and even though I should write an AND operator over here, but I did not write it over here. I'm not writing, just to explain a fact, and this thing is equals to greater than n3. So I'm going to see out a statement. If this condition is true, I'm going to say that maximum is, and I'm going to write n1 over here, and that's it. And if I did not write the AND statement over here, because this thing is, let's run this program and see what we get over here. So I write 0, 0, 1, and it says maximum is 0, even though the maximum was 1. So let's see what happened over here. it's actually a logical error, because the Boolean expression over here has integer values. So in the expression n1 greater than equal to n2, I mean n1 has the value of 0, n2 is the value of 0, and n3 has the value of 1. So I mean it should not print as per our understanding, but it says maximum is n1, which is 0, even though it was not. So this expression is evaluated from left to right. That means the first part, n1 greater than equal to n2, evaluates to true, because 0, if I write 0 over here, 0 is greater than equal to 0, so that thing is true. So let's write it as a comment over here. So I mean I entered the values of 0, 0 and 1, so 0 greater than equal to 0. So if I write 0 over here, that means this thing, I mean the answer for this expression would be 1. Reason is 0 is greater than or equal to 0. We are checking for that, so that means it is true. So that means this thing is 1. So this 1 is stored as, I mean in this, I mean as true, or true is stored as 1. So what we are seeing over here, that in this whole expression, since it's part evaluated from left to right, so this thing is now replaced, I mean it has evaluated it, it's now replaced with just 1. Now 1 is greater than or equal to n3. n3 was also 1. So if I mean this expression, I'm not writing, I'm saying the result of this expression is 1, and now it says 1 is greater than equal to, the value of n3 was 1. So if this thing is also true, because 1 is greater than or equal to 1, 1 is equal to 1 obviously, so or greater than or equal to 1, so obviously 1 is equals to 1. The answer for this whole expression would be just 1, and this expression, or this Boolean expression, evaluated to the integer value of 1 or true. So this program is actually syntactically, or if you're writing the code by the coding convention, this program is okay. But I mean the compiler did not catch any error. It's not a compile time error. When we were running the program, there was no error, so it was not a runtime error, but it's a logical error. I mean this logical error I mean is evaluated to true, even though it is actually false. 0 is not the maximum of 0, 0 and 1. So these things we need to watch out when we are watching when we are writing the Boolean expressions, because these compound conditions can become some tricky problems. So to solve this, I mean to correct this thing, I need to write this thing. So if I write AND operator over here, and n1 is greater than equal to n3, so n1 should be equal or greater than equal to n2, and n1 should be greater than or equal to n3 at the same time, then I should be writing that maximum is n1. So I'm going to write else as well, just to have a cout statement, even though it's not necessary. So I'm going to say that maximum is not, and I'm going to write n1 over here. So just run this code and see. I'm going to put the same input over here, 0, 0 and 1, and it says maximum is not 0. So I mean this thing actually ran over here. Now this condition is false, as we were supposed to happen, but we did not write the AND operator before. Actually we did not write this whole thing before, so this thing is kind of a logical error, because this expression evaluated to true, it stored 1, because this expression has the same precedence. I mean this and this operators have same precedence, so it's evaluated from left to right. So we have 1 over here, and 1 is greater than equal to n3. That was also true. So it was actually a logical error. Coming to the main topic, nested selection statements. Like compound statements, selection statements such as if else can be used whenever any other statement can be used. So a selection statement can be used within another selection statement. So if else statement or if can be used within another if block, it is possible. This is called nesting of statements. So let's write an example here. Once again, I've already saved this file before. I've written all the prerequisites to write the C++ program, so it's not going to prompt me to save the file. But if you're writing it first time, obviously, so it's going to prompt you to save the file with the name and the expression cpp. So let's do this. It's a very same example here, but we are going to do it a little bit differently. I'm going to write a selected or the nested if else statement over here, and let's first write the program. I'm going to just declare two variables, integer and d, and I'm going to say cout, and I'm going to say enter to positive integers, and I'm going to check whether something, whether it's actually divisible or not, and I'm going to take the input from the user using the input operator. First input is assigned to n, and the second input is assigned to d. Now pay attention over here. So if I write if, I'm going to check whether the denominator must not be equal to 0, otherwise should not run. We have explained that in the previous lecture because it will crash the program. So I'm going to say if d is not equal to 0. Now do the next thing. So if I write and then I write another if statement. This is a nested if statement. If I write if n remainder d is equals to 0, I'm going to check for that. I'm going to say cout. I'm going to say the same statement over here. D divides n, and that's it, and l. And I'm going to write else over here. Watch out the lines over here. If is coupled with this else, and I'm going to explain that in a moment. So else cout d, I'm going to say what was in the previous program, d does not divide. Okay, d doesn't divide. Okay, so I'm going to say d does not divide, and n over here. So I'm going to say and l, and I'm going to write another else statement. Else cout, and that's going to repeat the same line. Going to explain that why this thing actually going to be written twice. So does not divide and n, does not divide n, and that's it. So first run this program to check whether this thing is true. The program runs okay. So I'm going to write 10 and 2. So it says 2 divides 10. There was, obviously the remainder is 0. Let's run this program again. I'm going to say 11 and 2. So say 2 doesn't divide 11. So the program runs okay, no problem with that. And one last thing, let's check 10 and 0. So it says 0 doesn't divide 10. So the program did not crash. It ran perfectly. Now to explain that, why, how is this thing is a nested if statement. This thing is enclosed within this statement. If you want to, you can write just to explain that. If you want to, you can use curly brackets. So I'm going to delete this curly bracket, and I'm going to say if anybody wants to do that, even though we have singular line statements, so no problem at all. So I can do this as well, and I can use, just to explain it, even though it's simply not necessary to use those curly brackets, because these statements have just single lines with them. So over here, so this if is, this if else statement is nested within the if clause of the first if else statement. So the second if else statement will only execute when this condition is true. So this statement, this has to be used twice here, because the first one nested within this statement over here executes only when d is not equal to 0 and percentage and remainder t is equal to 0. The second one executes, this one executes when this condition is false. So these nested statements, so I'm going to remove these curly brackets because this thing is perfectly explainable by the indentation we have used. By indentation I mean I've used the tab characters. So actually in Python you just use tab characters, so no problem at all. So let's check it out how it works. Here d is should not equal to 0, and only if this statement is true, the control is transferred over here. So if this condition is false, the control is not transferred over here. This control goes to the else here, and because this condition was false, if I put the divisor or the denominator equals to 0, so 0 is not equal to 0, this condition becomes false, and this else statement will run, and it will print out that d doesn't divide n, which we have seen by running this code. Now if this condition is true, then it will go to this block, and it will check whether n remainder d is equal to 0. So I mean, let's say if I press 10 as numerator and 2 as denominator, so 10 remainder d is equal to 0. 0 equals 0. We have checked that, so this condition becomes true, and this cout will run. Now if this condition is false, let's say we have entered the values of 11 and 2, so it checked whether the denominator is not equal to 0, so this condition 2 is not equal to 0, this condition, the evaluation of this condition or the Boolean expression becomes 1, so that is true, that it enters here. Now 11 remainder d, that the answer of that would be 11 remainder 2 would be 1. 1 is 1 equal to 0. This condition would evaluate to false because 1 is not equal to 0. So this condition will only evaluate to true when we have 0 over here, which is equal to 0. So we are going to checking for the equality. 1 is not equal to 0, so this condition becomes false, and this statement did not run, and this statement ran that this thing doesn't divide, the denominator doesn't divide the numerator. Now if this condition is false, so the control is not transferred over here, the control directly goes to this else statement, and it says the denominator doesn't divide the numerator. So it's actually why I did not use the curly brackets, because in each if else statement there is just one statement to run. So actually this if statement ends, or the scope of this statement ends at the very first semicolon. So let's try to look at the possibilities over here. So if this condition is true, either this thing is true or this thing is true. So that means that if this condition is true, so if this and this is true, this if statement ends at this first semicolon, because I am not using the curly brackets. Now if this condition is true but this condition is false, so this if the control transfer to this else statement and it ends at this semicolon, so that means that this if statement ends at this semicolon, and the else statement also ends at the very first semicolon it encounters. Now if this condition is false, the control is transferred to this else, and because this is the outside else, actually I'm going to explain that in a moment what inside and outside means. This outside else, the control is transferred to outside else if this condition is false, and this if and else statement ends at the very first semicolon it encounters. Now if you are not happy with not using the curly brackets, you can use curly brackets. So let's see how I can do that. So I'm using the curly brackets over here. Then this if statement runs up to here. So and this is statement, sorry, not square brackets. This statement runs from here to here, and this else statement, even though this is just a single statement, I do not need to use the curly brackets, but if somebody wants to, he can or she can. Okay, so now it becomes really clear that this if statement is going from here to here, and this if statement bodies goes from here to here, and this else statement code block goes from here to here. Now this else statement, it goes from here to here. So I mean, even though I have used the single statement and the single semicolon, I did not need to use the curly brackets, but if anybody wants to, most welcome to use them, no problem at all. So I mean, this thing behaves exactly the same way, because if I have like multiple statements over here, yes, I need to use these curly brackets, but if I have just one statement with a single semicolon over here, I do not need to use the curly brackets. Even I mean, I could have just written this whole line here, no problem at all, and I mean I could just deleted those curly brackets, I mean no problem at all, and I can just, to make it even more simple, I can just write the whole line over here. So I mean, just to make it more clear, so sometimes minimalist style is the most most simple thing to follow. So I can just write something like, I mean no need for these curly brackets, and I can just write instead of writing this whole cout over here, I can just cut paste over here, because I'm going to say that if this condition is not true, then run this thing, and you can see that this code is actually now much more easy to understand. That, oh okay, this condition is true, go to here, if this condition is true, run this thing, else this can run this thing, because single statements, no problem at all. If you want to write multiple statements, You can write multiple statements over here with using the curly brackets, no problem at all. And you can write multiple statements in the same line provided that they are separated by a semicolon. So I mean, it should not be a problem anymore. So I mean, I think it's now much simple to write the statement in a single line, and just by using the indentation over here, I mean the indentation of what I mean by indentation is using the tab over here, I can easily distinguish that which if and which else belongs to which if statement. Whenever we are using a nested if-else statement, the compiler uses this rule to parse the compound statement. By compound statement, I mean that here, if we are using multiple if-else statement nested within the if statement, this is actually known as a compound statement, because the if statement ends at the very first semicolon, but it can have multiple pathways over here. So you can just include them in curly brackets, which I've just explained it a few seconds ago. But the compiler uses this rule that match each else with the last unmatched if. So now I've typed a code which is kind of a pseudocode actually, but I mean, without explaining what this code actually does, actually it does nothing. It's just to explain if else statement. Let's say if somebody writes a code, even though this code is actually okay, but it's actually not that readable for humans. So to make it more readable, the code should be, instead of writing in this horrific coding style, we should be writing the code with proper indentation, just to make it more readable for the program writer or program reviewer. So let's say if this condition is whatever is true, and we are using nested if-else statements, this code can be written like this. So I mean, the rule is, let's revisit the rule, that match each else with the last unmatched if. So if we have let's take a look over here. So if a whatever this thing and this if statement is true, then it will go to here, else it will check whether it's, we are using the nested statement, so we are again checking whether if this condition is false, so it will go to this else. So this if is matched with this else. Now we are using again an if else statement, so we are using another nested if statement, but this if statement has another if statement, and this else statement matches with the last unmatched, which was this thing, and this else matches with this if statement. So that was okay. So this else statement, it will be matched to here. So if this condition is false, then the program control will jump over here, and then if this condition is false, then the program control will jump over here. So this else statement is coupled with this if, and this else is coupled with this if. Because this else is coupled with this if and this else is coupled with this if, the last unmatched if statement is here, and this else is coupled with this if statement. Here this else, even though all this all else and ifs are actually coupled, so the last if statement, the rule is the last unmatched over here. The last unmatched if statement over here is this thing. So this else is coupled with this if statement. It's kind of a convoluted logic over here, just to explain that whenever we are writing the nested if else statement, I mean, you can write multiple if statement if you want to. No need to write the else. I mean, else will only happen when the if condition is false. So another way to write is, I'm going to explain that in lecture 20, that this is using the else if construct. I mean, the exact same code from here. I mean, this code from here to here can be written like from here to here, or it can be written using the else if pairs whenever we are forming some parallel alternatives. We are going to explain that this else if construct in lecture number 21. In the previous lecture, in lecture 19, we did a simple program with a very simple logic to find the minimum of 3 numbers. We asked the user to enter 3 numbers, and we assigned them whatever the user has entered to n1, n2, and n3, and we checked whether n1 is less than n2 and n1 is less than n3, and we again check whether, I mean, if this thing is true, but even though if this actually ran, so the task was completed, but the compiler or the program runner actually checked these conditions as well as these conditions. Actually, if this condition is false, so it will probably not check due to short circuiting, but I've explained that. There is another way to write this program, which is here, but to explain that how it actually works, so I'm going to cut paste this program. I'm going to write this in Node. So I'm going to draw this thing. Actually not draw, I'm going to explain that how it actually works. So it says enter, I mean the very same process, enter three integers, and the user has entered n1, n2 and n3, and let's say a user has entered, for example, for n1 he has entered, or she has entered like 30, and n2 is 20, and n3 is 10. So let's see how it works. So n1 is 30 less than n2, which is 20. So 30 less than, this condition is false. So this is this statement, I mean this statement 30 less than 20, this condition is false. So the program is not entering this block over here because the condition is false over here. It will go to this else statement, and in this else statement it will check whether n2 is less than n3. So 20 less than 10, that condition is false as well. So it's going to not going to run this code because this condition is false. It will run just this thing, and it will say the minimum is n3, which is 10. Now let's run this program again, and I'm going to delete all these things, and let's say when we run this program again, and let's say the user has entered n1 equals to 10, n2 equals to 20, and n3 equals to 30. Actually, this is a really convoluted or complicated way to write this program. If you are not happy with this logic, I would suggest you go back to this, and this is the simplest way to write this program, and the best way to actually write this program, because here it's just demonstrating the nested if-else statement. There's a slight performance benefit over here, but not much, because program readability is actually more important, so that we can debug the program later. Here it's actually quite a difficult logic to follow, but let's say n1 equals to 10, n2 equals to 20, and n3 equals to 30, which the user has entered as asked by the program, and we're going to check whether 10 is less than and 2 is 20. So this condition is true. So answer of this whole bracket would be just 1, and this condition would run. I mean the control will now transfer to this block over here. So it will check n1 is less than n3, 10 is less than 30. So 10 less than 30, it will say yeah, cout is n1, and this it. I mean this thing would run. So if actually the condition here is 1, which is true, so this thing would not run. And since this if statement actually ran, so this else block is not going to run. Now just take a look at the I've done this as well. Let's try a different set over here, but I think it's self-explanatory that here this in just any run of the program, only two simple conditions are going to be evaluated. However, in this program, let's take that program here, 3 conditions are evaluated. Even though this condition is actually true, this condition becomes true, so it will see out this thing, but it will program will actually check this condition, and if this condition is true, it's going to check this condition as well. And if the program will check this condition, and this condition is, I mean, it's true or not, I'm not so saying that. If this condition is true or false, it's probably not going to check this condition. If this condition is true, then it will check this condition. So I'm not saying which is going to be run or not, but it's going to evaluate all these 3 Boolean expressions. But here in this code, it's only going to check just 2 Boolean expressions, but it's actually, I mean, slightly more efficient, but it's really complicated logic over here. So I mean, this program should not be considered really good writing. We should choose the simplicity to write the program. So I would still prefer writing this code over here, which is actually much more simple to follow. As a last example in this lecture, let's make a simple guessing game, which from user is asked to select numbers from 1 to 8, and from 1 to 8 we are going to ask a question and going to guess what the user has selected in its mind, what the number is. Before understanding the code, let's run this code here. I've typed it before. I mean, it's actually quite a large, quite a long code over here. So let's run this code and see what we get. Let's say pick a number from 1 to 8. Let's say I have picked a number 6, for example. So it's going to ask whether it's less than 5. I'm going to say no, it's not. So it's going to ask whether it's less than 7. I'm going to say yes, and it should be able to figure out that it's actually 6, but it's going to say whether it's less than 6. So I'm going to say no over here and say that your number which was selected is 6. So actually this behind the scene, what is actually going on, let's understand the algorithm first, and then we will understand what the code is all about. This thing is known as something known as binary search. By binary search, binary means 2. So let's say if we have a range of numbers, for example, if you have a range of numbers from 0 to, or maybe 1 to 100, we have from 1 to 3 all the way to 99 and 100, and we ask a user to select a number in his head or her head, that just pick a number or get, and we are going to guess the number by asking the questions. By binary search, it takes about log 2 of the total numbers twice. That means that if I take log 2 of 100, log 2 of 100 is log to the base 2 of 100 is 6.64. so that means that in about 7 questions, I can figure out the what the number the user has picked up in his or her head. So let's say if the user has I don't know the number, I'm just going to guess it, but just asking the question, just 7 questions, I can figure out the number. So let's say if the numbers are 1024, from 1 to 1024, the log of 1024, log 2 of 1024 is 10. So if I ask the user, let's select a number from 1 to 1000 or 1 to 1024, I can guess the number correctly by just asking 10 questions. Even though the range of number is going from 1 to 1024, just asking 10 questions, I can figure out where the number lies, because in each question I'm going to half the range. I'm going to cut the range in half, and then I'm going to select whether I'm going to ask whether the required number lies between that range or not. So in this program we are going from 1 to 8, so log 2 of total numbers from 1 to 8 are 8, so log 2 of 8 is 3. So just asking 3 questions, I can figure out what the number user has picked up in his head. So let's take an example, a simple example. Let's say the user has picked a number, for example 35. So I don't know what the number is, so I'm going to ask, I'm going to say the maximum number going from 1 to 100, the mid number is 50. So I'm going to ask whether the user has selected a number in his head as greater than 50 or less than 50. So I'm going to ask whether it's less than 50. If the user says yes, so my range goes from, instead of going from 1 to 100, my range will go from 1 to 50. If the user says no, my number is actually more than 50, so my range will go from 51 to 100. But here in this case, if I'm asking the user if your number which you have selected is less than 50, the user is going to say yes, it's less than 50. It's less than 50. So I'm going to say yes over here. So now I'm going to ask the user, I'm going to take the midpoint of 1 to 50 range, because the user has said that the picked up number in his head is less than 50. I don't know what that number is. The user knows, I don't know. So I'm going to ask whether that number is less than 25. The user says less than 25, user is going to say no. So that means in next step, the 25 was the midpoint from 1 to 50. Then the next step, my range will go from 25 to 50. So I'm going to ask 25 plus 50 divided by 2. The midpoint is about what is that, 75 divided by 2, 32.5. I'm going to say 33 over here. So I'm going to ask the user whether it's less than 33. So I'm going to half the range again. So user is going to say no, it's more than 33. So now my range will go from 34, 33, I've already checked that, so 34 to 50. 34 to 50. I'm going to figure out the midpoint over here. 34 plus 50 divided by 2 is 84, divided by 2 is 42. I'm going to ask for the user whether his number lies between 42 to 50. User is going to say no, it's not from more than 42, it's less than 42. So my range will go from 34 to 42. Then I'm going to take the Gains average here, and you can understand that after doing so many questions, about 7 questions, I can figure out what the number is. So now take an example of this code which we have written over here. The number goes from 1 2 3 4 5 6 7 8, and I have selected number 6. So it's going to ask, if you remember, it's going to ask, the first question was whether the number is less than 5. Now why it has selected less than 5, I mean like the range of numbers is actually should be actually 4 actually, but okay, so it's less than 5 is going to half the range over here. So half the range over here, I'm going to say no, it's not less than 5. So that means the range goes from 5 to 8 because it's not less than 5. So obviously it could be equal to 5 or more than I mean more than 5 all the way to 8. So coming back to the next question, it's going to ask whether the number is less than 7. So the midpoint between 5 and 8, I have not actually added the numbers. I will put the range in the if statement. So I'm going to ask whether the number is less than the question was less than 7. So by less than 7, so I'm going to say yes, it's less than 7. So then my range goes from 5 to 6. So the next question was in this example was, is your number less than 6? So obviously I'm referring to 5. So I'm going to say no, it's not less than 6. So that means that this number is actually 6. Had it been less than 6, the number would have been 5. Now coming to the code quickly, code is rather long. I'm going to probably post it in the lecture folder, if in lecture 20 folder in the class stream. So I mean the code is using this if statements and else statements a lot. So I'm going to say pick a number from 1 to 8, and I'm going to pick the answer variable is declared as character. So that would be just y for yes and n for no. So I'm going to take the input from the user. Is it less than 5? Is going to say no. So that means that answer is equal to y, which is the character. So that means the range lies from 1 to 4. If it's not, that means the range lies from here, because this is statement is coupled with this else statement over here. So I jump straight over to here. Is it less than 7? I'm going to say yes. So if the answer is equals to y, the range lies from here to here. So I'm going to say I'm going to less than 6. So I'm going to say take the input from the user. If it's okay, so I'm going to say it's 5. Otherwise I'm going to say your answer is 6. And that's how this if else statement works. You can pick other example. If the user has selected like 3, so I'm going to ask whether it's less than 5. I'm going to say yes over here, and this will be the control will be transferred to this because y is equal to y, and this thing is true. So I'm going to say whether it's less than 3. I'm going to say no. So this no is not equal to y. This statement is the control is transferred to this else statement. I'm going to ask whether it's less than 4. I'm going to say I mean did I select 4 over here? I'm going to say no. So I'm going to say your number is 4 over here. So just to recap, this is actually just binary search. We're using all the possibilities over here. And just to recap what we did over here, we did some Boolean expression discussion. We we saw some logical errors which might happen because the Boolean expressions evaluate to 1 or 0, and they might get some tricky conditions over there. And we said when we discussed the nested selection statements, and the parse tool is match each else with the last unmatched if, and we saw some examples of the nested if else statements.